All right, so this is from page 460. This is one of the ones I assigned for the second law of sines practice. I don't know how to do this one. Cool. Let's work through it together. My initial thought when I look at it is I'm probably going to use Pythagoreans because of the squares. If I had to choose a side to start with, I'm probably going to choose the left-hand side because it has a minus in it. Although I'm now second guessing that because I'm thinking maybe, no, I think I'll probably go with the left-hand side. So yeah, so let's fiddle around here and see what we can do. So I could change cotangent or cosine squared or both. Cotangent is cosecant squared minus 1. Is that going to help me up here? Not really. Cosine, I see. The thing is, I want them both, right? I'm wondering whether I'd be better off starting from the right-hand side. The other thing that maybe might work out is common denominator and try and get them into a single, because I know that we're trying to get this into a single term. This has two terms. So if I rewrote cotangent as cosine over sine, then I got them into a common denominator. That might be helpful. I don't know. So the suggestion to go back to, in the original equation, divide the left side and the right side by something. We can't do that because we can only work on one side at a time. We could try it and see what happens and then see, but we can't do a lot of the algebra stuff that we would normally do, like moving terms around in this identity. We can't do that with these proofs because we're only allowed to adjust one side at a time. Sometimes it's useful to think about what would happen because sometimes that gives us some insight on how to proceed. What are we going to do here? I'm going to try writing this and getting a common denominator and see if that helps. So cotangent squared is cosine squared over sine squared. And this is cosine squared x. And I could multiply this to get sine squared on the bottom. I could multiply it by sine squared over sine squared. I don't know if this is going anywhere or not. Just curious, did anybody get this to work out? This is number 29. Okay, I'm not asking for hints yet, but so now I've got, so this is going to end up being over sine squared. So I can write this whole thing over sine squared. So this would be cosine squared x minus cosine squared x times sine squared x. Y'all okay with that? Y'all know if this is going to play out or not? I'm kind of thinking it might actually. This should be a times. That's a times. So because this is like cosine squared x over 1. Are we okay there? That did kind of. I'm thinking about factoring the cosine squared out of these two terms because they're in both of them. That would give me 1 minus sine squared x. 1 minus sine squared is cosine squared, isn't it? Yeah. I think that gets us there. Cosine squared x. 1 minus sine squared is cosine squared. And then I would split it up into two fractions. So we could do cosine squared x over 1 times cosine squared x over sine squared x. I was kind of looking back up at the top to see where I needed to go. I think that's gonna get us there. So yeah, that's one way to do it anyways. I don't know, there might be others. But I changed everything into sines and cosines and then got a common denominator. And the thing in the original problem that made me think that might be a good idea was I was starting with something with two terms, ending with something with one terms. And a lot of times if you can get a common denominator and combine two fractions together, that ends up getting you to the one term. I just know because I've done problems like this a lot. Nobody came up with another solution for that. I'm sure there's another way to do it. I wonder if I'd started with the other side of the equation, change this into 1 minus sine squared, if we could have probably gotten there as well. Cosine squared is 1 minus sine squared. Then I could have distributed the code. That would have been even faster. Totally. Like we could have done that in like 3 steps if I'd started with this. I'm just curious. I think 3 steps. I'm starting with the other side. Now, cosine squared x times cotangent squared x. It would have been way quicker to start with the other side. Leave the cotangent alone because it's part of what I need. Cosine squared is 1 minus sine squared. Distribute the cotangent. Sorry, I'm getting a little messy. And then I want the cotangent to stay there, right? And then if I turn this into cosine over sine, it would cancel the sines, and then we would just have the minus cosine. So that would get us there a lot quicker. It's actually starting from the other side. What other questions did y'all have? That was a fun one. 26. We'll try. I don't know for sure if I can. 26. 26. Secant x plus 1 over tangent x equals sine x over 1 minus cosine x. Just at first glance, this seems like one of those ones where I want to start with this and multiply by a fancy version of 1 and do it so that I end up getting 1 minus cosine squared on the bottom, because 1 minus cosine squared is equal to sine squared. We saw an example like that in our notes. So I'm thinking that's probably, I would almost certainly start with this side because it has subtraction in the denominator. That's more complicated to me. And I would look to use that whole a minus b times a plus b is equal to a squared minus b squared thing to turn this into 1 minus cosine squared. All right, it's already 1 minus cosine. I need to multiply it by 1 plus cosine, then it would be 1 minus cosine squared. So that's going to be my general strategy here. I don't know where it's going to go from there, but one plus cosine x over 1 plus cosine x. It's me, and I'm thinking whether I should distribute or not. I'm thinking maybe don't. Should I distribute? Yeah, maybe I'll go ahead and distribute here. So that would be sine x minus sine x cosine x. I don't know whether that was a mistake. I might end up factoring that sine x out later. That should be a plus though, shouldn't it? Sine x times 1, sine x times cosine x. There should be a plus in between. And this turns into 1 minus cosine squared x. Are you guys getting comfortable with this, like 1 minus something, 1 plus something, becoming 1 minus the thing squared? I've seen that pop up quite a bit. 1 minus cosine x is sine x, isn't it? Sine squared x. Sine x plus sine x cosine x over sine squared x. Oh, my bad. Yeah, probably should not have distributed that sine x. Because now I want to factor it, or now I want to cancel it. So causing myself extra work here, but whatever. So now I can cancel my sine x and my sine squared x. I didn't need to do this many steps, but over sine x, is that what we're trying to get? No, we're trying to get secant plus 1 over tangent. Whew. Oh, so we need like another one. So we're going to multiply it by a fancy one to make that happen. Secant plus 1 over tangent. This could be a secant if I divided it by cosine, agreed? 1 divided by cosine is secant. Cosine divided by cosine is 1, that's what we need. Sine divided by cosine is tangent. I think I would multiply times a really nasty fancy version of 1 over cosine x over 1 over cosine x. And that would get me there. I'll leave the last step to you guys. Could have saved myself 2 steps if I hadn't multiplied that sine x out, but oh well, we got there. How would you do that going the other way, I wonder? Get messy. Going the other way, I think you'd start by multiplying by tangent over tangent. If you multiply by tangent over tangent, did you try that? Multiply by, so going the other way, if you multiply by tangent over tangent, you'd end up with a tangent squared in the bottom. Tangent squared is secant squared minus 1, and you could factor that into secant minus 1, secant plus 1. Cancel that out up there. You'd have 1 over secant squared or secant minus 1, and then you'd have to just do some fancy versions of 1 to get what you needed there. I think that would be the start though. Multiply by tangent over tangent to get this into, yeah. Others, these get tricky. How about the law of sines? Is that going pretty well for you guys? Yeah, a little tedious sometimes when you got to do the 2 versions of the triangle, but is it a welcome change? At least it's kind of step-by-step cookie cutter. Anything else from the proofs? If you got some individual questions on those proofs, I'll be around to help you out with that. So let me stop this, show you something real quick.